Welcome back. Knowing how excited you were when we first began using the Pythagorean theorem, I prepared a special opportunity for you to dig even deeper into the magic of Pythagoras' brilliance. But first, a quick review of the Pythagorean theorem. As you recall, for all right triangles, side A squared plus side B squared equals C squared. C is always the hypotenuse in a right triangle. This diagram illustrates how, for side A, 4 squared equals 16 square units, and for side B, 3 squared equals 9 square units. Add 16 square units to 9 square units, and the result is 25 square units. Go ahead. Count all of the square units for each side to see if this adds up. I'll wait for you. That's great. We found that the hypotenuse is equal to 25 square units. But is this correct? Well, not entirely. We found that c squared equals 25 units. So what is the length of the hypotenuse? What else do we need to do to find this length? Look again at the Pythagorean theorem. Since we found the square of the hypotenuse, or c squared, we must now find the square root of the hypotenuse. The square root of 25 equals 5. Therefore, the length of the hypotenuse is 5 units long. Does our answer check out? Does the hypotenuse equal 5 units? Indeed it does. And now for the main purpose of this screencast, Pythagoras' assignment. Find and measure the sides of 4 different sized squares, like tiles, sofa pillows, pavers, in and around your home, and take a picture of each square and create a Google Slides document that shows each square object and its dimensions. Check out these examples of square objects in or around my home. Using the Pythagorean theorem, find the length of the diagonal of each of the square objects. Be sure to label your square objects with this measurement in Google Slides. For each square, find the ratio of the length of the diagonal to the length of a side of the square object. Remember that a ratio can look like a fraction. Record this ratio for each square in Slides. Compare the ratios of all 4 square objects. How are the ratios similar or different? What can you conclude? Can you find the relationship between the length of the diagonal and the length of the side of a square? Write a conclusion which describes this project and the square objects you choose to use. Explain the conclusion you arrived at based on the relationship you found when you calculated the ratio of the length of the diagonal to the length of a side for each square. Include this conclusion as a section in your Slides document, and as always, the full directions are located in your haiku page for this week. Remember to check the due date for this project. Be creative!